Ready to have your minds blown. Today, we're diving into the multiverse, and let me tell you, this isn't just some sci-fi fantasy.
It's true. We'll be exploring excerpts from the Multiverse, a collection of academic articles exploring the idea that our universe might not be the only one out there.
We're talking about the possibility of other universes existing alongside our own, each with its own unique set of laws, its own history, maybe even its own versions of us.
It's enough to make your head spin, right?
Absolutely. But don't worry, we're here to break it all down, cut through the jargon, and give you the most mind-blowing takeaways from these complex ideas.
Think of this as your crash course on the multiverse. What it is, why it matters, and how scientists are trying to figure out if it's actually real.
So where do we even begin? When we talk about the multiverse, what exactly are we talking about?
Well, it's not as simple as a single theory. Instead, the multiverse is more like a potential consequence predicted by several different theories in physics.
Okay, so multiple theories, multiple paths, potentially leading to multiple realities.
Exactly. And it's an idea that's been around a lot longer than you might think. We can trace it back centuries to philosophers like Leibniz.
Really? Philosophers were pondering parallel universes way back then.
Oh, absolutely. Leibniz, with his idea of the best of all possible worlds, was already toying with multiverse-like ideas in the 17th century.
Wow. I never realized the multiverse had such deep roots. It's amazing to think how long humans have been contemplating these big what-ifs about reality.
It really is. And then came Carnap and Lewis in the 20th century, who explored modal logic, the idea of possible worlds, which further shaped how we think about these concepts.
Fascinating. So we've got centuries of philosophical thought on this, but let's get down to the science here. One of the big players in the multiverse conversation is this thing called superstring theory. And I'll be honest, I'm going to need you to break this one down for me.
Okay, imagine this. Our universe is like a musical instrument, say a violin string. Superstring theory suggests that our universe isn't the only string out there.
Okay, I think I'm following so far.
Good. So instead of just one string, there's an entire orchestra of universes, each vibrating at a different frequency. Each frequency represents a different universe with its own unique set of physical laws.
So instead of one tune, one reality, there's this whole symphony of universes playing out all at once.
It's a captivating thought, isn't it? But
Right.
there's a catch. Superstring theory also predicts a swampland.
A swampland. Okay, now you're losing me.
Think of it this way. You know how a musical instrument can sound good, like music, or it can just be noise if it's out of tune. The swampland is like that. It's full of solutions that seem mathematically possible, but don't actually make sense physically.
Like they wouldn't actually work in a real universe.
Exactly. And that poses a major challenge. Physicists are trying to develop mathematical tools to differentiate between the music of real physically viable universes and the noise of the swampland.
That sounds incredibly complex. But I have to ask, even if we could sort through this swampland, how can we actually prove or disprove any of this? We can't exactly hop in a spaceship and travel to a parallel universe.
You've hit the nail on the head. That's one of the biggest challenges in the field. It's incredibly difficult to empirically test something we can't directly observe.
So how do we move forward? Are we just stuck with speculation?
Not necessarily. Some scientists are turning to non-empirical theory assessment. This means searching for indirect evidence rather than direct observation.
Indirect evidence. So what, like cosmic fingerprints?
You got it. We're talking about echoes or imprints that other universes might leave on our own.
Like whispers from another reality. Can you give us an example? What kind of echoes are we talking about?
Well, one example is the cold spot in the cosmic microwave background radiation. It's this faint afterglow of the Big Bang. And some scientists think it could be a bruise from our universe bumping into another universe in the distant past.
A cosmic fender bender. That's wild.
It really is a mind-boggling concept. They're looking for specific patterns imprinted in the fabric of space-time subtle variations in the cosmic background radiation, or maybe even gravitational waves that might have come from such an event.
So it's like a cosmic game of detective, trying to piece together the evidence of something that happened billions of years ago.
Precisely. And there's another challenge here. We're relying on superstring theory to potentially prove the existence of the multiverse, which is something that's predicted by superstring theory.
Hold on, so we're using a theory to prove itself. That feels a bit circular, doesn't it?
You've hit on a major point of debate within the scientific community. It's called the circularity risk. The search for independent evidence, something that doesn't solely rely on superstring theory, is crucial to move beyond this.
Okay, so lots of intriguing clues, but still a long way to go. This whole conversation about multiple universes really makes me think about the big why are we here kind of question. And that brings us to something called the anthropic principle.
Ah, the anthropic principle. It really gets to the heart of the fine-tuning problem. You see, the universe we live in seems remarkably fine-tuned for life.
Fine-tuned. What does that even mean in a cosmic sense?
It means that if the fundamental constants of physics were even slightly different, and I'm talking incredibly tiny variations, then life as we know it wouldn't exist.
Wait, so you're telling me that our universe just happened to hit the cosmic jackpot with the perfect settings for life? What are the chances?
Exactly. It's
Ah,
enough to make you wonder if it's all just a giant cosmic coincidence. And this is where the idea of the multiverse comes in. Some physicists believe it offers a rather elegant solution to this fine-tuning problem. Imagine a multiverse where there are countless universes, each with its own set of randomly assigned physical laws.
okay, I'm picturing it. Countless universes, endless possibilities. So in this scenario, our universe, with its seemingly fine-tuned conditions, isn't all that special.
Precisely. We might just be living in that one universe out of countless others, where the conditions happen to be just right for stars to form, planets to coalesce, and for life to emerge. And who knows what other strange and wonderful universes might be out there.
That's what I want to know. If we're talking about a multiverse where anything goes, does that mean there could be universes teeming with life? Maybe even more bizarre and diverse than we can imagine?
It's definitely a possibility. And to explore this idea, scientists have developed this concept called the habitability hierarchy.
A cosmic checklist of sorts.
Exactly. It's a way to figure out what makes a universe more or less suitable for life as we know it. And one of the first things on that list is photosynthesis.
Photosynthesis. You mean like plants and sunlight?
Exactly. For any universe to host life as we know it, photosynthesis is critical. It's the process that allows plants to convert sunlight into energy, which forms the base of the food chain. But here's the thing. For photosynthesis to work, certain physical constants, like the strength of the electromagnetic force, have to fall within a very, very specific range.
So even a tiny change and
No photosynthesis,
zero.
no plants, no food chain, no us.
It all comes back to those fundamental forces, doesn't it? What else is on this cosmic
It
checklist?
really does. Another crucial factor is plate tectonics.
Plate tectonics. You're saying those massive, slow-moving plates beneath our feet are essential for life on a universal scale. How so?
It's all about balance.
Mhm.
Plate tectonics play a vital role in regulating a planet's climate and recycling nutrients.
So no shifting continents, no habitable planet. Who knew geology was so important to the cosmos?
Right. It's all connected.
Mm.
But there's a catch. Plate tectonics aren't a guarantee. They depend on this delicate balance of a planet's mass, its internal heat, even the strength of its crust. A planet too small might not have enough internal heat to get things moving.
Too big.
Too big, and the pressure could lock the plates in place. No movement.
Fascinating. So size matters, and you mentioned internal heat too. That's from radioactive decay, right? Decaying elements inside the planet.
Exactly. The decay of radioactive elements in a planet's core is a major source of its internal heat, which can then influence volcanic activity and the movement of those tectonic plates.
It's incredible how these chain reactions deep within a planet could determine if it's capable of supporting life.
Absolutely. It highlights how interconnected these factors really are. But there's more. For a universe to be truly life-friendly, it can't be too chaotic either.
Too chaotic. How so?
Well, think about it. Catastrophic events like asteroid impacts, gamma ray bursts, massive volcanic eruptions, these can completely wipe out a planet's biosphere. Even the most resilient life needs a relatively stable environment to evolve and thrive.
Makes sense. It's like life needs a fighting chance to get a foothold before some cosmic catastrophe comes along and destroys it all. But on the other hand, wouldn't a universe that's too quiet, too stable, just lead to stagnation? Wouldn't evolution grind to a halt without some pressure to change and adapt?
Now you're thinking like a cosmologist. It's about
Mm.
finding that sweet spot, that delicate balance between extinction events and the time scale for life to recover and evolve.
Too many extinction events.
And life might never progress beyond simple, single-celled organisms. Too few. And there's not enough pressure for new, diverse, and ultimately intelligent life to arise.
What doesn't kill you makes you stronger.
Right. Right.
A little drama, a little cosmic chaos might be what pushes life to evolve.
Exactly. It's this interplay between stability and change,
Hmm.
between creation and destruction, that seems crucial for the emergence of complex life.
Okay, so we've talked about this habitability hierarchy and the things that might make a universe more or less hospitable for life. But this whole multiverse idea makes me wonder, is communication between universes even possible? Could we ever hope to send a message to another version of ourselves, or even get a message back?
That's where things get really interesting. And it might just be that quantum entanglement holds the key.
Okay, quantum entanglement. That's a term I've heard, but honestly, it still feels a bit like science fiction. Could you break that down for us?
I know it sounds like something out of Star Trek, but quantum entanglement is a very real phenomena. It's been experimentally verified. It describes how two particles, even separated by incredible distances, can be linked, influencing each other instantly.
Instantly, as in faster than the speed of light.
Exactly. And that's the truly remarkable part. This communication between entangled particles, it seems to happen instantaneously, regardless of the distance between them.
Wow. Okay, so how does this tie back to the multiverse?
Well, some scientists think that quantum entanglement might actually give us a glimpse into the workings of the multiverse.
Okay, I'm listening.
They theorized that entanglement could leave traces, imprints, in the cosmic microwave background radiation, that afterglow of the Big Bang. Imagine that. Faint whispers from other universes imprinted on the very fabric of our own.
So these whispers are like hidden messages encoded in the universe's baby pictures, and we just need to learn how to decode them.
It's an incredible thought. And it goes even deeper than that. Some scientists believe that quantum entanglement may have actually influenced cosmic inflation, that rapid expansion of the universe right after the Big Bang.
Hold on. You're saying that our universe's birth could be entangled with the birth of other universes?
It's mind-blowing, right? Imagine it. Quantum entanglement, a thread connecting different universes, letting them communicate, interact in subtle but really profound ways. And those interactions, if we could just figure out how to read them, might unlock the secrets of the multiverse.
Okay, my mind is officially blown. This is all so much to take in, and it's got me thinking, if our universe is just one of many, countless others, in a multiverse, what does that even mean for the very concept of uniqueness? It really makes you wonder what makes us special. If there are countless reasons of everything, does anything really matter?
It's a question that's been keeping philosophers and scientists up at night. Some people think that even if we prove the multiverse exists, it doesn't really change anything about our lives.
Because we're stuck here in this universe.
Right, at least with our current understanding of physics, we can't interact with these other universes. But for others, the very idea of the multiverse, it opens up all these new possibilities. It makes us rethink our place in the grand scheme of things and question what reality even is.
I can see how it would be both humbling and totally awe-inspiring at the same time. Humbling to think that everything we know, everything we care about, might just be one tiny story playing out among an infinite number of others.
Exactly. It's a huge perspective shift. But within that, there's also this sense of wonder. The multiverse tells us that the universe is even bigger, more complex, and stranger than we ever thought possible.
So where do we go from here? What are the next steps in this whole multiverse quest? What are scientists doing to try and solve these cosmic mysteries?
Well, they're working on a lot of different things. Some are coming up with new theoretical frameworks to try to model the multiverse and explore its consequences. But others are looking for actual evidence, those subtle signs, those fingerprints that other universes might have left behind.
Like those cosmic collisions, the quantum entanglements we talked about earlier.
Exactly. And as technology gets better, I'm talking new telescopes, particle accelerators, who knows what the future holds, we might be able to directly detect those whispers from other universes someday.
So it's a combination of mind-bending theoretical work and some serious cosmic detective work.
That's a great way to put it. It really takes the brightest minds from physics, cosmology, mathematics, even philosophy, all working together to tackle one of the biggest questions humanity has ever faced. Are we alone in the universe? Or are we just one of many realities in a mind-blowingly vast and diverse multiverse?
That's a question that'll probably keep us all guessing for generations to come. And who knows, maybe one day we'll have a definite answer.
And as we've seen, even if we don't, just exploring these ideas can lead to incredible discoveries about our own universe and the laws that make it tick.
Absolutely. Well, that brings our deep dive into the multiverse to an end. We hope you've enjoyed exploring these mind-bending concepts with us today.
And remember, the universe is full of incredible mysteries, both inside and outside our own reality, just waiting to be uncovered.
Thanks for joining us, everyone. Keep looking up and never stop asking the big questions.